Okay, so the next chapter that we're jumping into is chapter 12. It's all about statistics. So we're going to be talking about collecting some data and taking that data and finding out some information about it. Again, in this, we're going to do the bare bones of statistics. This is just kind of scratching the surface. Those of you that take statistics, you'll dive deeper into all this information when you take the I believe it's 2023 course that is statistics. That if you take that next. So again, we're just doing the bare bones of statistics. Most of the stuff you're going to kind of have seen and have known. Some of it I'm going to kind of give you some new twists on. So in 12.1, we're going to talk about the beginning of statistics, and that we're going to talk about surveys and displays. Because when you do statistics, it's basically like an analysis of a collection of data. Okay? And to get that collection of data, you've got to get out there and collect it somehow. You've got to find a way to gain that information. And usually, statisticians get that information through surveys. Okay? They send out some sort of questionnaire to whoever they're looking for, mainly their population or sample size, and from there they take that data and they collect it all and they analyze it through displays and lots of other methods of finding some information. And you can even find probability through statistics, which is why we talked about probability firsthand. But we're not going to do a lot of that. Again, that's more in the 2023 class. So, first things first, let's talk about surveys. I gotta collect some data. Well, there are a couple ways that you can collect data. There are different techniques on ways that we can sample and get data. The first one that I want to talk to you about is what we call systematic. Okay? And the idea behind systematic is I want to talk to every nth person. So say I stand at the door of our classroom and I want to talk to every third person that comes through the door. So I can stand there and I can go one person, two person. Oh, you're the third person. Let me ask you a question. And then the fourth person, the fifth person. Oh, you're the sixth person. Let me ask you a question. Then the seventh, the eighth. The ninth person, oh, let me ask you a question. That's what systematic is. And that was just an example of, say, I wanted to talk to every third person. Kind of like what Disney does when you go to Disney and you're exiting and you got those people that are out by the exit door saying, hey, can you take a quick survey? Hey, can you take a quick survey? They're kind of doing, in my mind, a systematic, because they're not going to talk to everybody. They're going to talk to every nth person. And I'm sure they're probably counting behind what's going on. Oh, person one's gone by. Person two's gone by. Hey, you're the third person. I want to talk to you. Person four's gone by. Person five's gone by. Hey, you're the sixth person. I want to talk to you. Again, I'm just using an example of 3, but they could be every fifth person. Hey, 1, 2, 3, 4. Hey, you're the fifth person. I want to talk to you. Then 6, 7, 8, 9, 10. Hey, you're the 10th person. I want to talk to you. Because that would be another set of 5 that have gone by. Okay, so that's what systematic is. You decide in your mind, I'm going to talk to every such and such number of person. Okay? Systematic. From there, we can talk about stratified. Stratified. Okay? What you do is you take your population and you divide them into subgroups. Population, when we talk about a population, it's the group that we want to study. Okay, that's what population means. A sample, just so we know, I got to kind of backtrack for a second. A sample is because usually I can't talk to everybody in the population. Like, say that our population is the entire United States. I can't talk to everybody in the United States. It's impossible. So what we do is what we call sampling, and these are different techniques to get those samples. You know, just like if I wanted to talk to the entire population of Valencia, we have a ton of campuses. I can't talk to everybody at every campus. So I use a sample, and then I use sampling techniques, okay, to help me get that sample collected. Because sometimes it is impossible to talk to the entire population. If we could talk to the entire population, that's what's best for us. If you have all the data about the population. But again, in the end, it's impossible to talk to the entire population sometimes. Like, for instance, one kind of population I could cover is maybe I just wanted to talk to everybody that is in this class right now. So there are 30 of you in this class. I could talk to each one of you. I could hit up all 30 of you. That's not hard for me to do. But if I wanted to talk to every student in college mathematics, then I'd be talking about every student at Valencia, and that's a lot of people again. I can't quite do that. I would have to do a sampling technique. Okay? So that's a little bit about populations. Populations are about everybody. A sample is like a snapshot of the population. I'm talking to a select few of those that are in the population. That's what I'm talking about here. So in the stratified, you're going to take the population and you're going to divide it into subgroups. Okay? Maybe I want to, like for instance, if I wanted to talk about those that are at Valencia, I could make subgroups of those of you that are dual enrolled students. And then I could have those of you that this is your first semester. Then I could have a group of those that this is the second semester. And then the third semester, and then the fourth semester. See how I made 5 different groups now. I've got dual enrollment. I've got first semester students. This is their second semester as a Valencia student. Third semester, fourth semester, fifth semester. So on and so forth. See right there, I've just made a couple subgroups. And then in these subgroups, we can sample people systematically or randomly. Like say I wanted everybody in each subgroup had an assigned number, and I want to speak to all the numbers that are those of you that had number 3, 10, and 15 assigned to you. So I would take whoever is 3, assign the number 3 in my subgroup of dual enrollment. I could take whoever was assigned number 3 in my subgroup of first semester students. I could take whoever was assigned number 3 in my students that are classified as second semester students. And then I can go back and I can survey the person that was assigned number 10 in my dual enrollment, number 10 in my first semester, number 10 in my second semester. And then I go back again, survey those of you that were assigned number 15 in first semester, number 15 in dual enrollment, number 15 in second semester. But again, notice that I'm taking it from each subgroup. Or I could do it systematically. Say I'm going to go through the subgroup, each subgroup, and I'm going to interview every 7th person. 1, 2, 3, 4, 5, 6, 7. I want you in my dual enrollment. 1, 2, 3, 4, 5, 6, 7. Oh, I want you in my first semester. 1, 2, 3, 4, 5, 6, 7. Oh, I want you in my second semester. And then I go back to the beginning. 8, 9, 10, 11, 12, 13, 14. I want you in the dual enrollment. 8, 9, 10, 11, 12, 13, 14. I want you in the first semester. 8, 9, 10, 11, 12, 13, 14. I want you in the second semester. So again, either whether you're doing it randomly, polling random people at general, that might have been assigned some number, you just don't know who they are, or whether you do it systematically. I want to survey every third person from each group. But again, in stratified, you're talking to each subgroup. You are pulling from each subgroup. We have another way to collect surveys, and that's through what we call cluster. A cluster is a lot like the stratified. Our population is divided into subgroups, but maybe we select one of those subgroups to look at to represent everybody. Or maybe we select more than one subgroup. The fact of the matter is you're not going to grab from every subgroup. Okay? So we're not going to grab from every subgroup. Whatever subgroups we choose, like maybe I just want to look at the dual enrollment kids to represent all of Valencia. I'm not saying this is entirely fair, but it's one way that we can sample. Or maybe I want to look at the students that are first semester students and second semester students. So there I chose 2 subgroups to randomly select from now. And again, once you choose those subgroups, which ones you want to narrow down, because you're not doing all of them, you're doing a select few. That's the difference between stratified and cluster. In stratified, you're doing each subgroup. But in cluster, you're selecting the subgroups you want to look at, and then you perform your either randomly selecting people or systematically selecting people. Okay? So that's how the cluster works versus the stratified. Stratified, you're pulling from every subgroup. Cluster, you're only pulling from one subgroup, or two, or three, just not all of them. You're going to pick and choose which subgroups you want. Again, not the greatest, but it is a sampling technique. And the last one that we'll talk about that is possible with surveying is convenience. You're just going to survey those that are convenient to you. For instance, I could survey all 30 of you in this class because that is a convenient. I have a captive audience. You're not going anywhere. And I can get your answers for whatever survey questions I need. That's called a convenience survey because you are conveniently right in front of me right now. Okay? So convenience survey is serving those of you that are around you right now. Like again, you could go down to the cafeteria and you could conveniently survey everyone that is in that cafeteria because they are a captive audience. They are there right then, right now. So that's what a convenience survey is. The fact of the matter is when you do a survey, you want it to be as random as possible. The more random it is, the more likely you're able to get a better feel for what the population wants. The more random it is, the more likely you will get a feel for what the population wants. So the very first problem you'll see in your assignment will show you this. And what they are doing, they've given you 4 choices here. They want to know which would be the most appropriate for obtaining a sample of the city's residents. We want to know which one of these will be the best sampling technique, okay, about the city's residents. So again, they're going to use some of those techniques that we talked about here, but we want the one that best encompasses everybody in the city. So think about the population and which one will best represent the population. So up here it says the government of a large city needs to determine whether the city's residents will support the construction of a new jail. The government decides to conduct a survey of a sample of the city's residents. Because again, it's hard to get everybody in the city to reply to something. But you could sample some of those to represent the whole. So we want to know which one of these samplings will be the best, the most appropriate. So again, we're trying to see whether we should build a new jail. So do you think it's best to randomly pick employees and inmates from an old jail? Would that best represent the city? To talk about the employees, or to talk to the employees and the inmates of an old jail? No. And again, the technique used here, we're just random, so we're just picking some people, but these people already work in maybe an overcrowded jail, okay, or live in an overcrowded jail. Would that really truly represent what the city residents want? No. So you throw this guy out, okay, because this does not represent the city. This represents the jail population, okay? We want the city population. So part B, survey every 5th person who walks into City Hall on a given day. So again, because we're talking about every 5th person, that's what we talked about a couple minutes ago. That's systematic. But is this the best method? Would we get a good representation of the city's residents for those who walk into City Hall? And again, the answer to that question is no. You're not going to get a good representation of the city. Because who goes to City Hall? Pretty much only those that work in City Hall. Unless they're having some sort of meeting. And do all city residents usually attend a City Hall meeting? No. Only the ones that have something to complain about usually. So does this represent a good sampling of the city's residents? No, it doesn't. What about this one? Survey a random sample of persons within each geographic region of the city. So think of geographic region as each zip code in the city. So if I sample people from each zip code, does that represent the city as best as I can? Absolutely. That one is the one that we want. This is the best way to figure out what the city it really wants. Okay? Should we support the new construction of a new jail? Well, if we survey randomly a whole bunch of people in this zip code, and a whole bunch of people in that zip code, and a whole bunch of people in that zip code over there. So what you're looking at here, this is that stratified system right here. Because we're going to sample from each geographic region. Okay? If you look at the last one, it doesn't make any sense. It says survey the first 200 people listed in the city's telephone book. Well, who are the first 200 people in this telephone book going to be? Everybody that has an A at the beginning of their last name. Is that fair? Does everybody with an A represent your entire city? No. So again, that's why the last one doesn't work, And again, this one is almost like a systematic because you're just looking at the A's in a telephone book. And in fact, you're just looking at the first 200. So again, overall, out of these four ways, this method is the best because I'm touching every region of the city and I'm getting information from every region of the city. And that's who we care about, the city's residents. So your first question is going to be something like that. They're going to be using some of those strategies that we talked about, like stratified. They use random sample up here. They use systematic. And they want to know which one best covers everybody. Okay? All right, from here, I went ahead and did a convenience survey because I wanted to get some data because after we get this data, we want to be able to talk about displays of it, which will allow us to talk about a lot of other objects, or not objects, ideas that we will talk about in 12.2 and 12.3 and 12.4 and things like that. So the first thing we needed to do, we need to get some information. So I asked those how many times, and my convenience was in the plaza when I was doing tutoring, and there were 24 of us down there. So I interviewed 24 people conveniently in the plaza. How many times have they been to Disney this year? And again, when I said Disney, I told them that include Disney Springs, the Disney theme parks, the water parks, the resorts, and Disney Wide World of Sports. So anytime they set foot on Disney property, I don't care how long it was, anytime they set foot on Disney property, I wanted to know how many times was that in 1 year. And of course, they roughly ballparked it. So here's the data I found in no particular order. Again, there are 24 pieces here. So out of the 24 people, and myself is included in this data, some people said 0, some said 5, one person said 1. There were some 3s in there. There was an 80, a 2, a 230, a 45, a 7, a 10, a 6, and a 216. So those are the results. 24 of them are here of the data that I took conveniently from the plaza. So again, this is a rough estimate of 1 year of going to anywhere on Disney. Now, when you collect data, the best thing it can tell you for everything that's going to happen here in a couple minutes is take your data and put it in order. Take your data and put it in order. Okay? And that's not hard to do. So you take your data, you put it in order, and here's what you got. Again, as I put my data in order, I start marking off those pieces that I've used. And once I'm done putting my data in order, I count it all up to make sure that there were 24. This is the part where when you put your data in order, if something goes wrong, it's because you missed one of these data entries. So make sure that if you start with 24 pieces of information, in the end you have 24 pieces of information when you've put it in order. And again, like I said, all I do is I start making my data entries right here. So I have a 0, cross it off. I have another 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 0 right here. Cross it off. I have another 0 right there, cross it off. Now I've taken care of all my zeros, so now I have a 1, cross it off. Now there's another 1, cross it off, and you get the picture. So as you're going through your data, I highly encourage you, cross off what you've already used. So that way you don't get lost through the end and miss something, okay? So here's our data. Another way you could do this, because we're going to use our calculator a lot in this, okay? We can actually take all that data and put it in and let our calculator do the sorting for us, which is great. Our calculator can take this data. Where are we going to put it? Right here under Stat. So you click on Stat, it's right here. 2 spaces over from the alpha, it says Stat. And we want to edit because we're going to put all of our data that we just had into the edit position. So when you hit edit, notice, oh, we got all these great things that line up. We got all these different lists, list 1, list 2, list 3, list 4, list 5. We want to take all that data and we want to put it under list 1. And again, when you put that in here, you don't have to put it in order because we can tell the calculator to put it in order for us. So I can go back to my original set of data here and I can go in and put all that information into the calculator. So I've got 0, and then a 5, and then a 5. So I can push 0, enter, 5, enter, 5, enter. And I keep going, and notice as this thing goes up, this number, the very last one I should put in, this number should be 24. That way you know that you have all your data. So again, I go back over here. I've got a 1, 0, 0, 0, and a 3 and a 0. So 1, 3 zeros, a 3, and a 0. So I got a 1, enter, 0, enter, 0, enter, 0, enter, 3, enter, 0, enter. So there was that information I just had a moment ago. Now I go back. What else do I've got? So I've got a 1, an 80, a 2, a 230. A 1, an 80, a 1, an 80, a 2, and a 230. So again, that's that data that I just saw right here. And then I got a 45, a 3, a 5, and a 7 over here. A 45, a 3, a 5, and a 7. 45, a 3, a 5, and a 7. And then after that, I have 10, 2, 0, 1. 10, 2, 0, 1. And then right after that, going back to my list, I've got a 6, a 3, a 216. A 6, a 3, a 216. Notice my last number as I enter it. Oh, it says 24. Yay, that means I got all my values. So like I said, our calculator can put this in order. Here's how that's going to work. So we put all of our data in, and I want you to hit Stat again. And right here, number 2 and number 3 allows you to put your data in order. This says sort A, which means sort ascending. So that means it will start at the smallest value and work its way to the highest value, which is what we want. Right here, this sort D means sort descending. So sort D would start at the highest value and then go to the lowest. So here's how you do those. Again, we put our list in. It's in L1. That's important to know. So hit Stat, come down, and tell it to sort ascending. But it won't do that yet because your calculator is going to play dumb. And your calculator says, sort ascend what? Well, that's what you see right over here in blue. See these L1, L2, L3, L6, L5, L4. Where did we put our list? In L1. So how do I get to this blue L1? Hit second and 1. Notice it says list 1. Now hit enter and it will say done. So if you go back into your stat and go back in and look under edit, just hit enter again, your list is now in order. Ta-da! And you can just write down all these numbers that you need. So again, our calculator can do that. Again, how did that work? Under stat, 2 and 3 are what you need. Really, just the number 2, because we want it to ascend, get from smallest to the largest. So you scroll down to number 2, and you tell it what list to sort. Again, all of our lists should be in L1. So hit second, 1, hit enter, and it's done. And you can go back in to stat and hit enter to look at your list. That's important for us. So let's go back here. We now have our list in order. There they are. All 24 pieces. And on your calculator, they're there. Because I'm going to show you a lot of cool things that your calculator can do for us to help us out. Okay? So now we're going to start taking and making displays. So there are a couple displays we're going to focus in on. One is called a frequency distribution. Then we'll talk about a histogram. Then we'll talk about a stem and leaf plot. And then in there we'll mention some other types of graphs like a polygraph. It's called a polygon graph, which I also call a line graph. We'll talk about bar graphs, and we'll talk about pie charts. Okay? But the ones that we really want to focus in on are frequency distributions, histograms, and stem and leaf plots. If you know those 3, you'll be just fine. So frequency distribution. Let me show you what it looks like. Here's a frequency distribution. Sometimes we call them tally tables. Because all you're going to do is mark out how many times an entry happens. So this is one way to do it. Okay? So notice we have what are called classes over here. Sometimes they act as just numbers, like 1, 2, 3, 4, 5. So you have some sort of, class or maybe number, and then you mark how many times it happens, or how many of our data entries fall within 40 to 49, or 50 to 59. Okay? And then over here, this is just what we call the frequency, because we turned the tally into its actual number. There were 3 tallies, so the frequency is 3. There were 6 tallies, so the frequency is 6. So that's what a frequency/tally table looks like. You're filling in how many times each one of these happened, or how many of our data entries happen in there. Again, another kind of tally table looks like this. You could say, you could have called it test score, and we could call it frequency. And again, we could have a test score of 50, 51, 52, 53. How many 50s were there? Oh, there were 2 that got 50s. How many 51s were there? There were none. How many 52s were there? None. How many 53s were there? 7. And of course the table would happen on. Again, I'm just making up those numbers. I'm just showing you the different ways. Sometimes they're just numbers and you tell me how many times they happened. Sometimes they're split up into classes and you tell me how many times our data values fell within each class, each range of values. Those are the 2 type of tally tables that you're going to see, or what we call frequency tables. Again, how do we make these? So what are the features of a frequency distribution that are expected? Well, if you go back here and look at these, notice that all of these have some sort of title, because I got to know what I'm looking at. All frequencies have some sort of title. What are we dealing with here? Because if I just gave you a table with no title, how do you know what's going on? Okay? And then from here, this is a very involved frequency table right here. But really, for most frequency tables, there are only two columns. The rows depend upon what we're dealing with. So, your table should have two columns. The right column is the frequency. How many times does such and such happen? The left column is what this is all about. Okay? So this is what it's all about. That's what goes on that side. And again, as I said in here, in the about piece, sometimes we list these as classes. 0 to 5. 6 to 11. 12 to 17. Okay? These are what we call classes. Or we just list them out as individual numbers. 0, 1, 2, 3, 4, 5, so on and so forth. So again, that left side, they'll either look like classes or they will just be listed out in numbers. That's the two ways that you will see the left side written up. Okay? Cool thing is, you don't have to really make the actual table. They will actually have the table ready for you. You just have to fill in the frequencies. So let's take that data that we had before and let's fill in a frequency table, a frequency distribution, because this is all that's needed. Again, you need a title. I need to know what this left side is about. The right side is always what we call the frequency. So here, I have begun the frequency table. The only thing that I didn't put on this is a title. Okay? You know what the left side is about, number of trips to Disney. The right side is the frequency. So what would be a good title to this? Well, your title should be as descriptive as possible. Where did this information come from that I got? I got it from the plaza. Okay? What is the information that I gathered? I gathered the number of trips to Disney. And specifically, I put in parentheses that a trip to Disney, to me, meant that they set foot on a resort. They set foot at any of the theme parks. They set foot at Disney Springs. They set foot at the Wide World of Sports. Or they set foot at any of the water parks. So any of those 5 regions, that should be noted in my title in a parenthesis. Okay? So a good title for this, even though I didn't put it up there, it should be there. A title to this should be number of trips to Disney, and in parentheses, all that information I talked about. Wide World of Sports, the theme parks, the water parks, the resorts, and Disney Springs. So number of trips to Disney for individuals in the plaza at 3 o'clock. Because that's when I actually did my survey, at 3 o'clock. So again, it's descriptive and it tells us what the table's about. And when we get to the table, it's now kind of like simplifying the information down. Oh, this side's about trips to Disney. This side is how many times did it occur. Okay? So notice this first interval is from 0 to 15. So I need to know for this frequency how many of our data entries happened from 0 to 15. This is where tallies come up. So this is 0. Does 0 fall in 0 to 15? Yes. And so up here, you can use a little bit of tallies to help you out. So I have at least one tally there. The next one, and notice I cross it off. 0. Well, that happens in 0 to 15. Then the next one. 0. Well, that happens in 0 to 15. Then the next one. Another 0. That happens within 0 to 15. And then there's another 0 and another 0 after that. There are technically 6 zeros total, and I can cross all those off. 1, does it happen between 0 and 15? Absolutely. So I believe there were 3 1s. 3. And I can come down and cross those off. 1, 2, 3. The 2s are definitely between 0 and 15, and there are 2 of those. So 1, 2. There are 3 3s, and that's definitely between 0 and 15. 1, 2, 3. There are 2 5s. Nope, 3 5s. So I'll make another set of 3 tallies up above. 1, 2, 3. There is 1 6, 1 7, and 1 10. And again, all the 6, the 7, and the 10 all happen between 0 and 15. So the 6, the 7, and the 10. So now you know the frequency for 0 to 15. How many tally marks are there? There are 20. So I can erase my tallies and actually put in here 20. So now I go back down and I look, do I have any tallies between 16 and 31? Oh, I can mark off my 7, my 10, and my 6. So, no, I don't have any numbers, any data entries down here that are between 16 and 31. So my frequency is 0. Do I have any between 32 and 47? So I come down here. Absolutely, the 45 is between 32 and 47. So I have 1. Oops. My fault. So then we continue on. 48 through 63. Nope. Okay. So that's a 0. 64 through 79. Nope. So that's a 0. 80 through 95. Absolutely. I've got an 80. So there's 1 there. 96 through 111. Nope. 111 through 126. Nope. I know this because my next number is 216, which was my value. So the next one is 0. The one after that is 0. The one following that guy is still 0. The next one after that is 0. We're getting closer. Not 191 to 206 is 0. 207 to 222, absolutely, we got one of those. That was my value. And then last but not least, 222 to 230, we've got one value in there. That right here is our frequency table. 20 of these values fell within 0 to 15. None of these values fell within 16 to 31. There was one value within this class, 0, 0, 1 value within this class, 0, 0, 0, 0, 0, 0, 0, 0, 1 value, and 1 value. And again, if you total all this up, it should be 24. Okay? So again, this one was shown to you as classes, but it could have easily been 0, 1, 2, 3, 4, 5, 6, but that would just be a pain to write all the way out to 230. So you can see why sometimes classes are a little bit better than writing out your numbers. Sometimes it's better to use classes. Okay? But we could have easily done numbers. Real quick, kind of just talking about that then. If these were numbers, all we would put is how many zeros did I have? Oh, I would have had 6. How many 1s did I have? Oh, I had 3. How many 2s did I have? Oh, I had 2. So that's what would happen if they were numbers. You just put how many of those entries there are. But again, using numbers on this would have been crazy. Actually, let's go back. Let's put what we had a moment ago. Yeah, there's our frequency table back. Because I want to use this information in a couple minutes. That's a frequency table. That's all it is. Figuring out how many data values follow within each one. Okay? So, now let's talk about a histogram. In order to build a histogram, you need the frequency table. Because all you're going to do for a histogram is you're making a special bar graph. Okay? And the bars must touch, and the bars must be the same width. So to show you the difference, right over here, the one about the box office receipts, this is a bar graph. These bars are not touching. But over here, you can see those classes that I kind of talked about over there, and you can see that these bars are the same width, and they all touch, because each class leads into the next class. Notice this class ends at 35 and goes into 36. This class ends at 40 and then goes into 41. That's why we call a histogram a specialized bar graph, because the bars will touch each other because each class leads into the next number. If they were numbered on our frequency table, like this was 0, 1, 2, 3, 4, 5, 6, see how each number leads into the next. And again, those bars would touch. Okay? So if our frequency table was just numbers, like this leads into the next number, 0. The next number after that is 1. The next number after 1 is 2. And again, your bars would be the same width, and they would touch. That's what it means to be a histogram. You must touch, and you must be the same width. Okay? Again, the reason why you're the same width is because if you look at all these classes down here, they're all contain the same amount of numbers. 31 to 35 contains 5 numbers. 31, 32, 33, 34, 35. Oh, that's the same amount of numbers. Look at the next guy, 36 to 40. That contains 5 numbers. 36, 37, 38, 39, 40. That's 5 numbers. Hence the reason for them all to be the same width, because each one of these classes is the same amount of numbers. If you go back to my frequency table over here, all of these classes are 16 numbers apart. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I counted out 16 numbers. This next class width is 16 numbers. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. I counted out 16 numbers. All of these classes are 16 numbers apart. So when I draw their widths, they all have to be the same, because each class is the same width. So, histograms. Very important that your bars touch, and very important that they're the same width, because all of your classes are the same width. The same numbers apart. So keep that in mind. Again, if you have to make classes, well actually you won't have to make classes. If they talk about classes, they will be given to you. Okay? So they will provide all the information. You won't have to make your own classes like what we had over here. I did that work for you. The book will do that work for you. They will give you the classes. You just got to fill in the frequencies. Okay? So, how do we make a histogram? Well, let's take a look at what we see over here. So notice each one of these, even the bar graphs up at the top, we have titles. So your histogram better have a title. And then you'll have your giant L. Okay? What's cool about this, all you need to do is take your frequency table here, and these represent your X and Y axis. You just got to label them for us and then put all the information on there. The left-hand column represents the x-axis. The right-hand column, the frequencies, represent the y-axis. So when we go over here, down here, this is what your histogram is about. The number of trips to Disney. And then you put all of your classes down here. Okay? 0 to 15. 16 to 31. 31 to whatever the next guy was. I believe it was 46. Okay? Sorry, that wouldn't pick up at 31. That would pick up at 32, which would be 47. Let me erase that. Let's fix this guy real quick. So it would start at 32 and go to 47. So you just list all those classes down here at the bottom. And again, as I said over here, this guy, get out of this and focus in on this. This guy over here is your frequency, which I just abbreviated with like a curvy F. And your highest value here should be whatever the top frequency is. The top frequency number. Okay? That will be the highest your bars go. And of course, the lowest could be 0. All right? Couple other things that are interesting about this. Sometimes our classes do not start at 0, like ours do right here. This starts at 0, so that will make the frequencies a little bit easier. Sometimes, like what you see in this bar graph, they'll start at 31. Okay? When that happens, even though this book has some real bad habits, you should put what I call the heartbeat in here. The heartbeat that you saw me put right there means that I'm skipping some values and I'm jumping all the way out to 31 to begin. Okay? If you are skipping values to jump out to a certain number, put the little heartbeat there. And again, that happens on your x-axis here. That's where you should have a heartbeat. If you start at 0, no heartbeat. On your frequency, your highest value should be pretty much your highest tally. Okay? So, again, if your classes do not start at 0 or your numbers do not start at 0, put a little heartbeat in there and then tell me where you begin at. Okay? So, that's what it takes to be a histogram. You have a title. Down here goes the left-hand column. What is it it's about with each of its classes. And then up here goes your frequency. And then all you will do from there is make your graphs. Or in other words, make your, bars. And again, these bars must touch and they must be the same width. So these two bars look about the same width. And then this bar looks up, notice that bar's a little thin. So go back and fix it. The bar that I had just a moment ago that I erased, I went back and fixed because it was too thick. So all these bars must be the same width that you draw in. And again, the height goes to whatever the tally was for that class. So you're going to see that here in a moment because we are going to take this frequency table that we have right here and we are going to make a histogram out of it. So let's talk about how we do that. Let me pin it in place real quick. There we go. Grab my pen, put it up here. So let's make a histogram. So the first thing is title. This should be the same title that we had for the frequency table, for the frequency distribution. So number of trips to Disney, which means that they have set foot at the resorts, the theme parks, the water parks, Disney Springs, or the wide world of sports. I'm just kind of abbreviating this so I can get to the main part. So number of trips to Disney, from the plaza at 3 p.m. That was roughly what our title was. Okay? So now I know where it's coming from. I know when I got it. You know, your title should be descriptive. Okay? If I was surveying you guys, then I would say number of trips to Disney from Mr. Armstrong's, when did we have this class? 9:30 a.m. class. Or if you're in my later class in the day, Mr. Armstrong's college mathematics 1 o'clock class, number of trips to Disney, something along those lines. Let us know where you're getting this information. Okay? So now that I got the title, I can start making my histogram. So again, my x-axis is all about number of trips to Disney. My y-axis is the frequency. Okay, it didn't really write frequency for me. Give this a moment. Okay, it's not here. Let me do this. Frequency. Grab this. Come over here. Spin it. There we go. That's a little better. Okay. What is my highest frequency? If you look over at that chart, it's 20. What would be an easy way to count? Well, you could count by ones. That wouldn't be too bad. It's not that hard. 2s, 5s, 4s, whatever you want to count by. I'm going to count by 5s. I got 5, 10, 15, and maybe I should move that 20 down just to help me out. So, oops. Let's do this. Grab this stuff. We'll move it up here. We'll grab this stuff. We'll move it down. So again, this side is all about the frequency. Okay, down here, number of trips. So all you do is you put your classes. And since we start at 0, we'll start right here. 0 to 15. And actually, there are 17 classes over here. So I'm going to kind of mark out where my bar should be so I can kind of keep them the same length. So there's 1 bar, 2, 3, 4, 5, 6, 7, 8, 9, 10. And obviously I'm going to run out of room, but you're getting the idea of what to do. So you got 0 to 15. You got 16 to 31. 32 to 47. 48 to 63. 64 to 79. 80 to 95, 96 to 111, 111 to 126, 127 to 142. Oh, I messed up. Notice I had the same numbers here. This should have been 112. My fault. Well, we'll just go with it anyway. It would have been zeros and all them. And these guys would still be the same down here. They'd still be 1 and 1s out there. But that was my fault. Yeah, this guy should have been 112. And that meant that this should have been 127. So each one of these numbers just get bumped up 1. So this would have been 128, 143, 144, 159. That still doesn't change any of these frequencies. 160, 175, 176 to 191, 192 to 207, 208 to 223, 4 2 and again I would have messed up there because again I used the same stupid numbers. That was my fault. Again, I'm a ding dong. So since I went up by 2 here, I need to go this guy up by 2, so that would be 239. So these are the real intervals. My bad, I'm sorry. But it still doesn't change the frequencies over there. It's still all those zeros and then 1 and 1. So let's see here. This is 140. So that should have been a 12. Let's just fix this real quick. So 1 1 2 2 1 2 7 1 2 8 2 1 4 3 1 4 3 2 1 4 4, and you get the idea. We continue on. Okay? So once you get all that, that's the hard part right there. All we do now, just like what we talked about before, we make bars. So 0 to 15 is all the way up here at 20. So there's my first bar. 16 to 31 is down here at 0. So don't raise your bar any. The next guy is a 1, so it's just up a little ways. Okay? And then after that, it's 0 and 0 and then a 1. And then I've got a bunch of zeros here. 0, 0. Again, all these bars should touch. Okay? And then I would go back up at 1 at these two guys. And that's what your histogram would look like. Not the prettiest histogram, but it is a histogram nonetheless. Okay? So, again, this guy would keep going out there. Don't do the ... that I do. You actually need to have all those classes all the way out. Okay? There should be 17 bars up here, but I only did the first 10, I believe. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. Again, there should be 7 more bars for over here. Okay? Most of them at 0, and the last 2 up at 1. And again, all these bars are touching, and all these bars are the same width. That's important. And I've got my title up here, and I've got my labels on my y-axis and my label on my x-axis. Again, the cool part in this, you're not going to have to make any of these by hand. What they will do in your assignment is they will give you the frequency table, and then it will be a multiple choice down below. They will have 4 choices for the histogram. You pick which one is the histogram that represents it. Okay? So just make sure that all the frequencies match the frequencies that are in the distribution table. That's all you got to do. Okay? Now, from here, I'm going to go ahead and mention it now. They are going to talk to you about and ask you about a polygon graph. Okay? A polygon display. All a polygon display does is it connects each bar to each other in the middle. So a polygon graph will start at 0, and then you're going to connect to the middle of every bar that you have with a line. So what I have done in blue, that is a polygon graph. Okay? So over here, since this is my histogram, if I want to make a polygon graph, I will connect to the middle of every bar. And that will be my polygon graph. Whoa, come back. So, I connect, I connect, I connect, 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 connect. That's a polygon graph. In other words, it's a bar graph. It's kind of the same thing of a bar graph. Because on a bar graph, you would plot your points and then you would just connect the dots. Okay? Polygon graph is a bar graph. And so what they will do in your assignment, again, in that same problem where you just found the histogram, right below it, there will be 4 choices, each one showing a polygon graph. Just make sure that the polygon graph matches the histogram graph. Okay? As if you were connecting each dot at the middle of your histogram. So if we come over here to ours, we would be looking for a graph that connects this point, that guy, that guy, that guy, this one right there, that one right there, that one right there, that one right there, that one right there, and of course we'd have the others. And since this one started at 0, I don't need to start down here at 0. So you'll connect. That's horrible. Let's redo that. I'll go up to it. That's a little bit easier. Close enough. What are you doing? That's horrible, but closer. Connect, 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 connect. Over, over, over. And of course you'd keep going. And again, you would look down below for a polygon graph that matches that. That's what a polygon graph is. It's like a bar graph. Or excuse me, it's like a line graph. Okay? And again, I'll show you a line graph here in a couple of minutes just to reiterate kind of the fact that they look the same. Okay? So you start at your 0 and you just connect the middle of each bar, and that's a polygon graph. All right, that's the hardest part of all this. So we got that done. 2 of our displays done. Frequency table or frequency distribution. We've got the histogram done. Now we need to talk about a stem and leaf plot. Let me show you what a stem and leaf plot look like. And again, in your assignment, they will make most of this pretty easy for you. So stem and leaf plot, here's what it is. So down here, I've got the ages of Oscar-winning best actors and actresses. I've got a key over here that says 2/1 means it's 21. And over here, you see a stem and leaf plot. This is actually a back-to-back stem and leaf plot. It's a double stem and leaf plot. So if you want, let's just focus in on half of this. Let's focus in on this side, the actresses. Okay? So that's what a stem and leaf plot looks like. You have what is called the stem, you have what is called the leaves. Okay? Usually this side is called leaves. We don't really say actresses, but the reason they put the actresses on this one is because the other side was all about actors. So because it's a double stem and leaf plot, they kind of label what they are. You won't have to worry about a double. So notice we have what are called the stems, and then we have all these leaves. Notice the leaves are all spaced evenly. Okay? Everybody is evenly spaced. The 7 lines up with the 3. The 6 lines up with the 3. The 6 lines up with the 1. The 6 lines up with the 1. And the same thing on down. Everybody is evenly spaced out. Okay? And everybody is in line with those that are above them. Also notice that there are no commas between these. Okay? So this isn't one long number. This is all a bunch of individual numbers. This is 0. That was one of our entries. 0, 1, 1, 3. None of these numbers are together. Okay? So again, down here, you have 5 data entries right here. You've got a 1, a 1, a 1, a 2, and a 9. Okay? So stem and leaf plots, no commas in here. Don't use commas. Although, again, like I said, our book has bad habits. When you do your assignment, they will want you to separate these numbers with commas. I hate it with a passion, but please do not use commas on a real stem and leaf plot. That's what the spacing is used for. Okay? So, no commas here. But when you do your assignment, it will tell you to separate them with commas. I hate that. It's in bad form. Also notice that your numbers are in order from least to greatest. when you do a stem and leaf plot, your leaves are in order from least to greatest. Again, these are what we call the leaves. Everything is nice and evenly spaced out, no commas, in order from least to greatest. Over here are what are called your stems. And again, you have a title, you have a key. So let's talk about how do we create these? Always a title, just like everything else. If you give us a display, there has to be a title for your display. What am I looking at? And then for you guys, you'll have a stem and you'll have leaves. Okay? All of your stems will go over here in order from least to greatest. No skipping of numbers. Do not skip numbers on your leaves. Excuse me, on your stem. And then over here will go the leaves, which we'll talk about here in a moment. And of course, you will have a key, because the key tells us how to interpret your stem and leaf plot. You'll understand what I mean by that here in just a moment. Okay? Again, over here in your stems, they are in order from least to greatest, and we do not skip numbers. Over here are your leaves from smallest to largest. Spacing should be uniform for all vertical and horizontal leaves. And again, you should have a key and a title. So, let's talk about stem and leaves real quick. How do we make stem and leaves from data entries? So let's say I've got these data entries up here. I've got 6 of them. Here's how you make a stem versus a leaf. The leaf is the last number. The stem is, or maybe are, because there may be more than one value for the stem, all the numbers before the leaf. So in other words, you can think of, when I say the last number, it is the last number on the left. Sorry, right. On the right-hand side. Find the rightmost digit, and that is the leaf. Everybody before that right digit is a stem. So when I look at 27 right here, 7 is the rightmost digit. It is the last number. I cut it right in front of that. Anybody before that line is a stem. Anybody after that line is a leaf. So if I look at 345, this is the rightmost number. Cut it. 34 is your stem. 5 is the leaf. Try these other 6. See what you think. Okay. The rightmost number is 7. Cut it. So that means 104 is the stem. The leaf is 7. I'll get to these two over here in just a moment, but let's talk about this decimal one right here. Again, our rightmost number is 6. Cut it. The 0.45 is a stem, and it's okay to have decimals as stems. That's A-okay. So this 0.45 is your stem. The 6 is the leaf. Now let's talk about these two. 6 is the rightmost number. Cut it. But now you're going to be like, well, Mr. Armstrong, there's no number in front of it. Technically there is. We just don't write it. And no, it's not the number 1. If it was a number 1, then that number would have looked like 16. What number's in front of the 6? 0. That's really how the number 6 looks when it comes to stem and leaves. Your stem is actually 0. The 6 is actually the leaf. Over here, you can think about the same thing. I put 0.5, but what number is really in front of the point? A 0. So if 5 is my rightmost number and I cut it, my stem is 0. Now this is why we have a key, because notice these two right here look the same. 0/6, 0/5. You won't see that decimal there. The only way you can tell the difference between these two is by the key. So over here, the key would say that this is a value of 6. Over here, the key would say this is 0.5. That's how you know how your digit is ran. And the same thing up here. Without the key telling us that this is 345, if I didn't have a key, well, what if this was supposed to be 34.5? The key tells us how to interpret the numbers on the stem and leaf. And the same thing that's in here. The key will tell us that this is 1047. If I didn't have the key, well, another way I could interpret this is 104.7. Without the key, I wouldn't know if it was this number or that one. That's why the key is important in your stem and leaf plot, because the key tells us how to read the numbers on the stem and leaf plot. All right, so now that we know how to make stems and leaves, let's talk about our information. Let's make a stem and leaf plot. So again, the first thing we need is a title. Well, that's not too hard to come by. We already know the title. It's the same title that we've been using on everybody else. So right here is my title for the stem and leaf plot. Copy. Let's see if it will actually paste for me. Paste. Oh, there it is. Beautiful. So let's group all this together. And I want to shrink this title down. Woo, too small. So there's my title. Close enough. So number of trips to Disney, talking about trips being resorts, theme parks, water parks, Disney Springs, what the Wonderful World, Wide World of Sports. And I got this information from the plaza at 3 p.m. So again, we're going to make stem, and over here will be the leaves. So we need to go up and we need to look at what are our stems and what are our leaves. All right, so I'm going to extend that guy just a little bit more. So all these numbers that are right here are what we just got done talking about a moment ago. These are all the rightmost number. So what is the number in front of 0 here? 0. This is the rightmost number. What is the number in front of 1? 0. This is the rightmost number. What is the number in front of 2? 0. And the trend continues. This is why having your data in order makes things a whole heck of a lot easier for you, because we can actually look at it. So we know that one of our stems is 0. And we can put all the data entries that go behind it. And there are a total of 20 of these entries. You can see them all up there. So again, we're not going to put any commas, but we're going to evenly space them. So I have 6 zeros. See how I'm trying to evenly space these as best as I can. I have 3 ones. Again, I'm not using commas because the spacing is what we need. There are 3 2s, I believe. Nope, 2 2s. Let's make sure on my ones that there were 3 of them. Yeah, there are 3. I have 3 3s, 3 5s. So 3, 3, 3, 5, 5, 5, and then I have a 6 and a 7. We never ever break leaves into 2 rows. Your leaves should be all 1 row, and everybody should be evenly spaced. Okay? So now we work to the next piece. So we look at our next number. It's 10. 0 is the rightmost. So now you know the stem. Now you know the leaf. So we've got a 1. And over here I have a 0 for a leaf. Notice, oh, it's lined up. That should happen. As we start working our way down, things should get lined up across. So let's take a look at our next one. 5 is the rightmost. Cut it. 4 is our stem. But I told you a couple minutes ago, when we start doing this, we do not skip values. So our next stem, logically, in the transition is 2. And then we have 3. And then we have 4. So because there are no data entries for 2, that means we didn't have any 20s. We didn't have any 30s. You leave those blank. But we did have a 45. So we write our leaf. Notice it's lining up in the 45 spot. Okay? Notice I didn't skip any stems. We went from 0 to 1, 2, 3, 4. So here's our next guy. Here's the rightmost number. Cut it. There's your stem. So again, I'm not going to go from 4 and just write 8 down. It doesn't work like that. You include everybody in between 4 and 8. So we got 5, 6, 7, 8. And now I put my 0 in. And again, it should be lining up. And again, there's no information for these guys because there were no 50s, 60s, or 70s. And then we keep moving on. Here's my rightmost digit. I cut it. Now my stem is 21. So from here, again, this is what makes stem and leaf plots long. I would now have to count out all the way to 21. Now, the stem and leaf plots that you will have to deal with, you won't have to do this. It'll be nice and easy. But I will go 9, 10, 11, and I keep going until I get to 21, where I will put a 6 right here. And then the last stem that you will have to worry about, cut it, is going out to 23. And then you'll put a 0 on there. Okay? That's how a stem and leaf plot is made. One more thing that we have to include is a key. So that just means you pick any one of your answers that you got here. I could use 0, 0. I could use a 0 and a 1. I could use a 0 and a 2. Or I could do the 4 / the 5. It doesn't matter. So pick one of these pieces. So I chose a 0 and the 3. And tell us what that means. 0 / 3 means the value 3. And that's the key. That tells us how to read these. So now I know that if I have a 1 / 0, that means 10. If I have a 4 / 5, that means 45. Okay? So that key is very important. It tells us how to interpret the stem and leaf plot. And there it is. The other thing that's really cool about a stem and leaf plot, a little bit harder to deal with the one that I had a moment ago, but let's go back to this stem and leaf plot. If I take my stem and leaf plot and I turn it sideways, if everything is spaced correctly and in rows correctly, then what you're looking at is another histogram. Oops. So there's your histogram, where this represents a frequency of 1, 2, 3, 4, 5, 6. This represents a frequency of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This represents a frequency of 1, 2, 3, 4, 5. Frequency of 3, a frequency of 1, a frequency of 1. It's a histogram. That's what a stem and leaf plot is. There's another histogram. And down here, these are your classes. This is 20 to 29. This represents 30 to 39. 40 to 49. 50 to 59. There was no one. 60 to 69. And you get the picture. Stem and leaf plots are just another version of a histogram. Okay? All you got to do is turn your stem and leaf plot vertical. And you can see your histogram. And again, just to remind you, you can take a histogram and make a polygon out of it. Because again, a polygon connects from the middle of every box. There's the polygon of your histogram. Kind of cool. All right. So those are the 3 displays that you have to know. And again, like I said, in your assignment, they will actually have your stem and leaf plot set up for you. So it will actually say stem, and it will be like 7, 8, 9. And then over here, you'll have leaves. And they'll give you a data set, like 71, 83, 72, 92, 92, 80. And they'll want you to take these numbers and put them into the stem and leaf plot. Okay? And again, in the assignment, they will say put commas between your answers. I hate that, but put commas between your answers. So if I look over here, what leaves do I have in my 70s? Well, over there, I got a 71 and a 72. So that means I have a leaf of 1 and a leaf of 2. So you put 1, 2 in that blank. For my 80s, I have a 3 and I have a 0. Again, it's best to put your numbers in order. Makes things easier. But when you're doing your assignment, they don't care on the order either. It annoys me. Again, this book has some bad habits. So if you put 3, 0, your answer will be fine. But it would be better if you wrote out 0, 3. And then for the 90s, I've got a 2 and a 2. And yes, you do write both of those out. Okay? It's okay to repeat leaves. So that's what a stem and leaf plot would look for that data over there. And that's what your assignment would be like. They're going to already have the stems ready for you. You just have to fill in the leaves based off of the data that they provide you. Okay? That's the big bulk of this section. There's a couple other things that, again, that I want to talk to you about. There are the displays, like the bar graph and the line graph and a pie chart. First, let's look at the bar graph. Again, I already showed you the bar graph earlier. This is the same one. This bar graph, again, in a bar graph, the bars do not have to touch. Okay? In the bar graphs, the bars do not have to touch. So you can see each one of these bars, and then over here kind of like represents the frequency or what the bars made, like as in money over here. Or it could have been the number of people that saw the movie Chicago, and so on and so forth. So bar graphs, not necessarily always frequency on this side. It could be a question about the bar graphs. Like, again, we could have had bar graphs where we talked about our favorite colors in class. So I could have had the blue bar graph. And I could have had a bar that represents how many people like blue in our class, that's their favorite color. I could have the yellow bar graph. And again, I would have a bar that represents how many people in the class that like yellow, and so on and so forth. Okay? So bar graphs, they don't have to be about numbers. Okay? They can be about, like objects. That's what makes a bar graph not really have to touch, because why would a blue bar graph touch a yellow bar graph? That doesn't make any sense. Blue does not lead into yellow. Okay? Like when we had numbers. Again, you see over here a line graph. Notice it looks just like a polygon graph. You're just not seeing the bars. Okay? Because technically there's a bar here that looks like that. And there's a bar here that looks like that. Okay? A line graph is a lot like that. All right? So other times that you do line graphs is when you talk about like plotting points over years, like when you want to talk about population growth and trends in population. So like in 2000, the Orlando population was 1.2 million. In 2001, the Orlando population is 1.3 million. In 2002, the Orlando population was 1 million. So you could plot those points. You could put 2000, put a dot up at 1.2 million. Then in 2001, you put a dot at 1.3 million. And then in 2003, you put a dot at 1 million. And you can connect those dots and see the trend. Okay, again, that's how line graphs are made. You're not actually going to have to make these. I just want to show you what they look like. Okay? And then a pie chart. A pie chart looks like a circle that's split up into lots of different wedges, like this. I have a pie chart with all these different wedges. That's a pie chart. Again, you don't have to make it. I just want to show you. And each wedge represents a percentage of your data. Each wedge represents a percentage of your data. Pie charts go really good with bar graphs. Pie charts are a little harder to do with histograms. Okay? Pie charts are a little harder to do with histograms, but they can be done. But pie charts really go good with bar graphs. All right? So those are some other displays that we can talk about. And the reason why we talk about these other displays is because sometimes displays are deceiving. Okay? So I've got 4 displays here that I want to talk about with you, and they are deceiving in ways. Okay? This is why it's important for you to understand what you're looking at when you look at displays and some things that you know about the displays. Because this display up here is deceiving. Take a moment, look at this display of a pie chart. Because in your assignment, they're going to give you displays at the end of this, and they're going to say, what's wrong with this? Because there is something severely wrong with this picture. So what do you think? Hopefully, you kind of looked at this and noticed that your pie chart, it really is making America look really cool. Okay? We've got a flag on our little pie chart. Everyone else has a little dinky color. Okay? But, other than that, making America look really good, did you notice anything about the percentages? Look at America's percent. It's 26%. But how much is the American wedge taking up? Half of the pie chart. If your wedge is taking up half the pie chart, your percentage better match that. That's what's deceiving about this. Is that half of America, or half of the pie chart is America, yet our percentage is only 29%. That makes no sense. Just don't make no sense. How could half of America be 29%? That's what's deceiving about this. They're trying to make America look amazing by all the space being taken up by it, but it really doesn't take up all that space. It takes up 29%. So that means there's some sort of wedge up here that's missing. That should have some other percentage. Deceiving. So look at this guy. The world population in billions. So if you look at this, it looks like a bar graph because my bars are not touching. But what's deceiving about this? Okay, so if you look at this, many of you will be like, well, this isn't deceiving, Mr. Armstrong. It makes sense, because as the years go by, my populations, the world population is growing. Absolutely. But if you look at this, as these bars are getting bigger, they look like they're getting bigger by just about the same amount. Actually, in the last few years, it kind of grows a little bit faster, but it almost looks like it's a steady step, right? But the problem is, look down here at the years. We start in 1804. And then where do we go to? 1927. That's a huge jump in time. That is a huge jump in time. This is deceiving. Because if I look right here, 1927 to 1960, that's not that much. This is a 100-year gap, over 100 years. This right here is a 40-year gap. And it looks like they move about the same amount. That's deceiving. That's throwing us off. This is an unfair jump compared to this guy, which is different from this jump. This is a 14-year gap, and all of these look like they move up the same amount. That's a problem. So when you look at displays, you need to look at what's going on. Is this trying to deceive me, or are they being pretty factual about it? Because again, these jumps in years are not constant. They're not the same amount of jumps. That's an unfair jump from over 100 years to 40 years to 14 years to 13 years to 12 years and then to 13 years and then another 14 years. See all these different jumps. This is 37-year jump. No. 13-year jump. Sorry. Not 13. 17-year jump. Now that's a little bit better. That's a 17-year jump right there. Not fair, considering this guy. Trying to say that, oh, our population is steadily increasing. Deceiving. Then there's this one. What's the matter with this? Percentage of U.S. households watching ABC, CBS, NBC, and in prime time. What's going on? So, hopefully one thing I hope you notice is the size of the pictures. That's deceiving, guys. I mean, if they're trying to make this look like a bar graph, these bars are different widths. Look at this bar. And then there's this bar. And then there's this small bar. And my bars keep getting smaller in width. Okay? So, that's deceiving. It's making you look like, oh, the 1972s to the 1973 were the best years ever. That's when they had the most people watching ABC, CBS, and NBC in prime time. But if you kind of even that out a little bit more, 56%, 51%, 37%, 22%, 18%. Now my bars are a little bit more stable. That's a little bit better. Okay? Other things, if you look at these, our classes are good. They're always going up by a year. But look at this last jump. All these have been 10 years apart. 10 years. 10 years. 10 years. 5 years. That's an unfair jump right there as well too. So there are some deceiving things about this. The size of your pictures. Of course, our televisions were huge back then. But that doesn't mean our televisions now are this small. That doesn't make any sense. Okay? So, and then also we have this unfair jump. Again, when you make displays, you don't make them deceiving. You need to make them so that people can actually understand what's going on. This is unfair. And then last but not least, last problem, I promise you. I know there's a lot in here. But when you look at this display, we've seen this one. It's a bar graph. What's deceiving about this? Yeah. If you look at this bar graph, we don't know which to look at. Are we supposed to look at the bar? Or are we supposed to look at where the picture stops? Because if you notice right here, they're pretty much the same. But when you look at this, here's where my bar is, but here's where the picture stops. Which one do I look at? Here's where the bar ends, but here's where the picture stops. Which one am I supposed to go after? Because some of these, the picture kind of matches the bar. So that's the deceiving part in this. Nothing else is deceiving other than which one do I look at? Do I look at the bar or am I supposed to look at the end of the picture? And again, right here, most of this bar is kind of covered up. Here's the end of my bar, but there's the end of my picture. Which one am I supposed to look at? They really want you looking at the bar. Okay? And guys, these are every graph that I've shown you, these are graphs that have been put out into the world. People have looked at these graphs and they've been published. Okay? This graph came from Entertainment Weekly. So this is a graph that was published in Entertainment Weekly. A little bit tough to decipher. All those pictures that I showed you before, they came from somewhere. Someone has published that information. And that's what 12.1 is about. You know, we talked about surveying techniques, and then from there, once we get this data, we can start making displays out of it. And you learn how to make a frequency distribution, you learn how to make a histogram, you learn how to make a stem and leaf plot. And the next couple sections that we start talking about, again, we're going to keep taking this data and we're going to keep morphing it, finding out some other information. Thanks.